Hello, my name is Yi, and I'm going to talk about my project, identify personal attacks in Wikipedia comments. The first thing I did is understand the data we have. We have two files, two files, the annotational files and the comments files. And the first thing I did is extract the attacks from annotational files and merge it into the comments file. The attacks column is equal to true if the majority annotator think it is an attack. And the reason I didn't use a number threshold is some of the comments may have only one annotational, and it's hard to determine the threshold. And another thing is the baseline of our project is the sample code that we get, and it's showed as the graph on the bottom. There are several features in our dataset, and some of them are useful, and some of them are useless. And I use the features such as logged in, sample, NS, and for example, the reason I use logged in is because through the visualizations and I plot the data in logged in column, and like this plot, we can see that the leftmost column is the quantity of the comments that is true, attack is false, and logged in is true, and the rightmost columns is represented quantity of the comments that is attack is true and the logged in is true. So we can clearly see that if the instance is logged in, and it is likely not an attack. And for useless feature, for example, year, we can see that the ratio of the comments, if the ratio of the comments that is not attack is similar to the ratio of true, the ratio of the comments that is attack as the year increase. So I think it's not an important features in this data set. Then before I apply the data into the models, I clean the most important data in our data set, the comments. So the first thing I did is try to see if there's any empty data in the data set. But there's no empty data or null data, so it is good. Then I find the longest comments in the whole columns and see what's going on in the comments. And I saw a lot of punctuations, so I removed them after that. Then I tried a couple classifiers, but and two of them are not available because it takes too long time to run it. And the best one here is logistic regression, which is the same in sample code, but it gives a nice result. Then after I use grid search to find the best parameters for the models, I found here's the best parameters, and finally, after I applied the best parameters, the result increased by 3% in F1 scores. And that's all. Thanks.